All right, one final example that we're going to do, and this is the type that we would ask you to do these last two examples. Those are the only word problems we'll encounter. We're not going to worry about distance, rate, and time or any of the other types. Okay, I like this problem because this is really a calculus problem. We kind of used calculus to get the answer, but now we're going to see what the quantities would give us the answer that we desire. Okay, so here's the scenario we have. A farmer has $1,500 available and he wants to build a fence along the river. Okay, and I drew the picture ahead of time. Here's the river, and we're going to assume that no fence is needed along that edge. Okay, now we have to come up with two variables. Okay, and he talks about the material for the side parallel to the river. So let's call that distance y. Okay? For no good reason, well, a little bit of a good reason that I chose y for that distance. And then the materials for the three sides perpendicular, I'm going to call this distance x. And those are my two variables. Okay? So now the first thing I have to come up with are two equations relating x and y. And so I go back to the body of the problem and I look and see that there are two things that we know. One is the amount of money that he has to build the fence, and the other is the area of the total pastures. That would be assuming that the fence in the middle is negligible to the area. Okay, let's do the easy equation first. What is the area of a rectangle? It's just going to be the product of those two dimensions. And we're told that that area is 6250. So we have an equation xy equals 6250. Secondly, we're going to deal with cost. Now we know that he's going to spend $1,500. We'll assume that he's going to spend all of it to build this fence. And so we have to figure out what's the cost. Well, notice that we have not just two sides, but we actually have four sides. Okay, or four, I should say 4 lengths. No fence along the river, 4 lengths. All right, let's look at one thing. Let's just look at the one long side. Okay, and that's assuming, doesn't necessarily have to end up that way, but the way I've drawn it. And we're told that the material for the side parallel to the river costs $6 a square foot. And how many square feet do we have? Y. So the cost is 6y. The cost per square foot times the number of square feet. Now we're told that the sides perpendicular to the river can use a little bit cheaper fence. It doesn't have to look so nice. And so that only costs $5 a square foot. So this length is 5x, but I have the same cost for the middle fence and the same cost for the other side. Okay, does that make sense? So I have the cost of all 4 sides, so I can write that as a single equation. 1,500 equals 6y plus 15x. Okay, and if I look at this, I notice that 3 goes into each of these, so I'm going to divide by 3 to get a little bit simpler equation. So that'll give me 500 equals 2y plus 5x. Okay? So now I have my system. One equation comes from the area. The other equation comes from the cost. Sorry, $500. Okay? And how do I solve that equation? I'm going to use substitution. Okay? This time I'm going to solve for y because I only have to double that. So let's solve for y. Okay? And so then I plug that into our second equation. So 2 times 6250 divided by x plus 5x equals 500. Okay? Now if I multiply 2 times that, I'm going to get what? 100, let's see, 2 times, that'll be 12,500 over x plus 5x equals 500. Let me double check that. 2 times 5 is 10. 2 times 5, yes, 12,500. Okay? Any questions about this? This is really leading into calculus, so you definitely want to understand the setup of this problem. Okay, now how do we solve that? Well, what do we do in general? We clear our fractions, okay? So I'm going to multiply x times both sides, well, x times each term, actually. To eliminate the x and that denominator. Okay? And again, this is a quadratic, so I'm going to get 0 on one side. 5x squared minus 500x plus 12,500 equals 0. And I think I'm going to make my number smaller. Let's divide by 5. Let's see, that'll be 2,500. Okay, so here I just divided by 5. Okay. And then, let's move up here so we have a little more room. That, if we look at it and try to factor it, it looks like it's going to be a perfect square, right? 2,500 is a perfect square. It's 50 squared. And you can check that it does factor. Okay. Or use your just techniques that you have for factoring a quadratic. Okay, and so x equals 50. Right, and if x equals 50, y equals 6250 over 50, which is, if you work that out, let's see, the zeros cancel, 5 goes into that, it's 125. So it looks like it should be, x should be 50 feet, and y should equal 125 feet. Okay? And I'm going to leave the checking step to you. To check, you go back to this equation and you plug in and make sure that it works, and it will. Okay, that system of equations, and that's where we'll end. That's all that we'll be responsible for Lecture 19. Thank you.